the Hamilton City Council Emerging Scientist Award.
There's been quite a lot of concern in the last 5 or 10 years in New Zealand about water quality due to intensive agriculture, sheep and beef farming and dairy farming. Both leach nutrients. The nutrients escape from these farming systems, both nitrogen and phosphorus, and these amounts might be quite small in agronomic terms, but once they reach the waterways they can lead to problems such as algal blooms or in some places even toxicity to humans and stock. So the way that I contribute to that argument is by trying to integrate science from a broad range of areas into a consistent mathematical framework, and then looking at ways that it can be used to inform policy making. I think a feature of my work or a characteristic of my work is that I've modelled at a lot of different scales. One project that I've been working on where we've sought to identify cost-effective ways to reduce greenhouse gas emissions, that was at a single farm level. But at another level, a few years ago we constructed a system where we represented 410 individual farms, and each farm was represented by a single model. Each mathematical model was of a significant size, so the total model itself was about 4 million equations, so it was huge, and we managed to integrate them all in together and then look at, if we introduce certain policies, what effect would that have on the farms, what is the cost-effective way for each farm to respond, and also what is the total effect on leaching load or nutrient leaching coming from the farms. And that was quite interesting work because Environment Waikato had been talking about, they'd mentioned 2 policies that had been raised for reducing nitrate leaching in the Upper Waikato, were the banning of nitrogen fertiliser, which of course is very controversial, and another one is a stocking rate cap. We used the large catchment model to investigate that issue and showed that a stocking rate reduction was not going to work. It was going to be terribly costly, and it would also have very little water quality difference because it's actually cost effective for farmers to feed the cows more, and there'd be more cow urine hitting the ground, and more urinary nitrogen hitting the ground, and then more nitrate leaching. So that was actually that was quite an interesting one. And I was talking to a policy analyst at Environment Waikato last week, and they were saying that that's really taken it off the cards as an option. And another one was the banning of nitrogen fertiliser. We evaluated it and found that it was very ineffective. I think it would reduce profit by about 30%, but reduce leaching by about 5% or something. So it's just because it's a blunt instrument. So we could actually look in a mathematically formalised way, one that's consistent with science and integrates some key scientific principles. We can actually look at it and compare them on a level playing field, these alternative policies.